In this video, we're going to look at a confidence interval for a mean with a known sigma. So the question reads, data on investments in the high-tech industry by venture capitalists are compiled by Venture One Corporation and published in America's Network Telecom Investor Supplement. A random sample of 18 venture capital investments in the fiber optics business sector yielded the following data in millions of dollars. So our sample size is 18, and they give us all the values, and then they want to determine a 95% confidence interval for the mean amount mu of all venture capital investments in the fiber optics business sector. Assume that the population standard deviation is 2.04 million. And it says, note, the sum of the data is 113.97 million. And then it wants us to interpret the answer. And the first thing that I want to do is write down the formula. So we're going to have x bar plus or minus z alpha over 2 times sigma divided by the square root of n. And now I want to go through the problem and highlight all the important information. So they didn't exactly tell us x bar, but they told us that the sum of all the data is $113.97 million. So we're going to take that number and divide it by 18. So n was equal to 18. The sum of our xi's was equal to 113.97. So x bar is equal to 113.97 divided by 18, which is equal to 6.332. And now it's important to notice that it says the population standard deviation is 2.04. So that's what told us that we knew sigma and that we are using z distribution and that this would be the formula for our confidence interval. We want to do a 95% confidence interval. That's going to be important. And then our n was 18. So now we need to find z alpha over 2. We know that sigma is equal to 2.04, and we already have n written. So now we have all the variables written that we needed except for z alpha over 2. And we're doing a 95% confidence interval. So I'm going to go to my t-table, and I'm going to look at confidence level, 95%, and see that my z is equal to 1.960. Or we could use the z-table and find 0.9750 in the body, which is right here. And then we could see that it's 1.96. So it gives us the same value. And remember, you're looking at 0.9750 because if we drew a distribution and we were looking for a 95% confidence interval, there would be 2.5% in either side. So the distance from here all the way to here is 0.9750. And that's our positive critical value. So that's why you'd look up 0.975. Now back to our problem. We know that this is 1.96. And now we can use our formula to find our confidence interval. So we have x bar, which is 6.332, plus or minus z alpha over 2, 1.96, times sigma, 2.04, divided by the square root of n, the square root of 18. And when we calculate this, we get 6.332 plus or minus 0.9424. And generally we go one digit past our original data. So if I use 3 decimal places on my x bar, then I'm going to use 4 decimal places on my margin of error, which is what the right side of this formula represents. So now I have 5.3896 is less than mu is less than 7.2744. And remember, this was in millions of dollars. And you might also see the answer just with parentheses. So you could say 5.3896, comma, 7.2744. So we're saying the true mean of venture capital investments in the fiber optic sector is going to be between 5.3896 and 7.2744 millions of dollars. And now it wants us to interpret our answer. So we're going to say that this interval was constructed using a process that would 95% of the time in repeated samplings the same size and type as this one produce an interval that includes the true mean venture capital investment in the fiber optics business sector. And that's our video on confidence intervals for a mean with a known sigma.